So, quizzes over the first 3 sections. We started with just basic integration. I am not going to make you do limit theory. You can do your shortcuts on this. So for this one, you would just do individually. The first thing I would actually do here is I would rewrite it. So this is the same. I would rewrite this to 2x to the 1/4. And then you can just use your exponent. Multiply by the exponent, so that's -4. Subtract 1 from the exponent, that is 1. Again, multiply by the exponent. 2 times 1/4 is 1/2. Subtract 1 from the exponent, -3/4. And then, of course, you want to simplify that. So y equals -4x plus 1 over 2x to the +3/4. And that would be your final answer there. Nope. I'm going to actually box it. So if you will remember product rule, your function derivative will be the derivative of the first times the second plus the first derivative of the second. So if this is my first function, then the derivative of that function is going to be 9x squared. If this is my second function, then the derivative of that one is going to be 15x squared. And then I can just plug it in. The derivative of the first, 9x squared, times my second, 5x cubed plus 1. And then plus the first, and you can put this first since you're going to be distributing it. So the derivative of the second times the first. And of course, simplify it. You do want to distribute through 45x to the 5th plus 9x squared plus 45x to the 5th minus, what do I have here? 15, 25, so 75 x squared. And then, of course, combine like terms, 45 and 45 give us 90x to the 5th, +9, -75 gives us -66x squared. And that is our derivative. All right, the next page is all quotients. Some of them get really long, but same concept. For this one, remember your derivative is the derivative of the top times the bottom minus the derivative of the bottom pretty much times the top, or vice versa. This part's multiplication. I usually put that first if it's going to be a small one that I'm distributing. I put the small piece first. So I try to make it where the smaller of the two is up front when I'm distributing, so I remember to distribute that negative. But order doesn't really matter on the multiplication. It does on the subtraction. It is the derivative of the top times the second minus the derivative of the bottom times the first. So you have to make sure that part's in order. And then, of course, remember it is all over the original bottom squared. All right. And so the derivative of the top piece here is going to be 4x cubed. The derivative of the bottom piece here is going to just be 4x. And then I am going to do my formula. So the function here, when you take first derivative, is going to be the derivative of the top times the bottom minus, and this order actually doesn't matter because it's going to be 4x times x to the 4th, all over the bottom quantity squared. Distribute here, so we get 8x to the 5th minus 20x cubed minus 4x to the 5th, all over 2x squared minus 5 squared. Simplify as much as possible. 8 minus 4 gives you 4x to the 5th minus 20x cubed. I will not make you distribute the bottom. Pay attention, though, if it has a common factor. Had that been 2x squared minus 4, it's 2x squared minus 4, 2x squared minus 4. You could actually pull out a 4, a 2, and a 2 from each group. And you could have reduced it by 4. So pay attention to, is there a common factor in that group that I could potentially pull out and reduce with the top? That's the only time you have to concern yourself with, you know, what it could potentially be, okay? Other than that, you may leave it grouped. I think your answer key foils out the denominator. I do not require you to foil out the denominator, but I do require you to reduce when possible. This next group says to find the equation of the tangent line that is to the function at the given point. To find an equation of a line, we should know that is y equals mx plus b, which means we need our slope and our y-intercept. They've given us neither. Nor have they given us 2 points to find slope in the general pre-calculus way. And so we are going to have to then recall that in order to find slope of the tangent line, we can use first derivative at that x. And so the first thing we're going to want to do is find the slope using the first derivative. And so I'm going to say, well, let's find my first derivative first. That's negative 2x. Specifically, when we want to find it at the point 2, negative 2. Well, I need to plug in my x value there. So I'm going to say, well, my slope then is going to be what happens when I have negative 2 times that x value of 2. So my slope here is negative 4. I have one piece that I need in order to write my equation. Now I can use point slope because they gave me a point. I figured out my slope and I can use point slope. So you are going to use this guy, but anytime it asks for the equation, unless it's specific, you probably want to put it in slope intercept form. And I also want to point out that standardized tests will also put it in standard form. So always know how to recognize your answer in a multiple choice question, right? So we're going to do this guy. We're going to say y minus my y1, which is negative 2, equals m negative 4x minus my x1. So we have y plus 2 here. Distribute here. Negative 4x plus 8, subtract my 2. Y equals negative 4x plus 6. All right, that's how I want it. When I say standardized test like standard form, please recognize that this is the same thing as 4x plus y equals 6, which would be standard form here, okay? And I'm only saying that because PSAT, ACT, if they do, you know, equations of a line, they could potentially do y equals mx plus b or ax plus by equals c. So I want it in this form right here, which is what you'll see on your answer key. But always recognize your answer when it's written a different way. So, all right, so average rate of change is literally your slope formula, okay? So average rate of change, and I did not change it back. Average rate of change is your y2 minus y1 over x2 minus x1. They gave you x1, x2, okay? So they gave you x1 and x2. Had that been an x1, y1, it would have been parentheses, not brackets. Brackets indicates a range of numbers, not a coordinate point, okay? So in order to find y1, y2, you have to plug in your x1 and your x2, okay? So average rate of change is literally just slope in the way that we know it pre-cal. Instantaneous rate of change. So when they say instantaneous rate, that is at a specific point, which is what we just did. First derivative, so you want to find first derivative, and then plug in x. And they specify leftmost value, so they mean x1. So they are telling you to plug in x1. So you have two answers here. You have an average rate of change, and you have an instantaneous rate of change, okay? So if we find average rate of change, we first need to plug in our x1s and y1 and x2s to get what our y1 and y2 is. So our y1 then is going to just be 2. Our y2 is going to be what? 9/4 plus 4/4 will be what? 13/4. Okay. So we have our y1 and our y2 to find our average. And then we're just going to do that process. We're going to say, plug it in, our y2 minus our y1. And I'm going to go ahead and make a common denominator. So 2 over 1 is going to be 8 over 4. I'm just doing that, right? All over 3 halves minus 1. So we would say 2 halves there. And then you want to, simplify. 13 minus 8 is 5/4 divided by 1/2. Keep, change, flip, right? So 5/4 times 2 over 1 is 5 halves. And that is my average right there. So my average rate of change is 5. And I wrote a 3, but it is a 2. 5 halves. All right. That's my average. So that's my first answer. Instantaneous, I need to find my derivative. So instantaneous, my derivative is 2x. Specifically at my leftmost value here is 1. So plug in a 1. My average was 5 halves, but my instantaneous is just going to be 2.